There you go. Okay. Why? Right? Is it working? Right, so this. I think it's working. Hello everyone, and welcome to Decentral Bitmain L3 Plus Repair. So first timer for us and for me too. So today we will repair a bunch, we hope, of L3 Plus. So there's a bunch of them. Some of them, I think some of them I've worked on them some like few weeks, even few months ago. So we will just take back on them. Some others are just completely new. So it's always a little surprise with them. So let's hope, actually not hope, we will do our best. I did many of them, but as always, it's never 100% chance of success, even with these old ones. Some are quite easy and some are just a pain to repair. So without further ado, the first thing I am usually doing is a little physical checkup. Is it working? C'est pas? See, I'm talking to everyone. Yeah, go take a look and tell me if it's working. So yeah, first thing that I'm doing as many board repair. Sorry, I need to translate in my head. So I'm like Jonathan, I'm a French Canadian, so I need to translate sometimes in my head. So that's why the accent. So let's go back on those boards. First thing first that I like to do. Nice, it's working. So I'm not talking empty. Physical examination on those boards. On every board that you repair, could be S9, L3 pluses, 17, 19, if you are into them. Because you could put the tester on it right on, but if you got physical issues, you can damage the board and even damage yourself in the process. So it's always important to protect yourself, or even with those. If we are working on some harder boards, just in case of, I've seen some of them explode, and I think you saw some too if you got any experience in them. Let's see, let's take a look. So I am not at my desk, I am at the boss desk, so I need to see what are the angles, what could work. Okay. This is a close-up, nice. Let's see with this one first. Oh, better than that. Okay, first thing first. I have so right on the spot on the visual. If we are comparing, if you got like a working L3 Plus right from the start, keep it aside because it can be very useful for physical checkup. Also for values. If you got a good working board and you can have those values on the side, that's a super effective way to have a better better diagnose those dial test voltage and all that stuff. Also on those little L3 pluses, right from the start, a little trick. If you got many of them to repair, or even in the same machine, sometimes you could see that these are not the same revision. What I mean by that? Okay, what I mean by that, the same revision, L3 plus hashboard, 72 V1 161. Here I got a more common 141. So most of the time, these are quite the same. We got the booster right here. We got the MOSFET, and we can already tell that this one, somebody had tried to make a repair because the three MOSFET are missing, and it's always three, even if there's a fourth one here. I don't remember seeing one here. There's also the step down. So we got the booster here. We got the step down right here. Let me, if I can. Oh, is it working? Yeah. Woo, nice. Okay. So we got the MOSFET right here. But if we are checking the step down, it's not the same chip. So there's two completely different gen. Some part might work, but most of the time you cannot take those parts and put them here. You need to use your common sense a little bit on it. By example, MOSFETs that could fit depending on the generation. The pick here, most of the time it's, you can see here, we have I don't know if we see clearly. Where's the isopropyl alcohol? I'm gonna take it. Pop. So I just shot some isopropyl alcohol just to have a better view. Oh, okay, right on. So you see those pick most of the time. These are one or the other. Okay, I don't know if you could tell, but I'm just like I'm just not sure that. So at the end, what I want to explain is that there's like two different kind. Ah, this one. There's two. There's two different pick. Okay. Ah, pick 16F1704. So most of the time it's ending by 1704 or 1705. That's the only thing that I wanted to show you first. So all that time for that. But that's great. That's great. We're gonna I'm gonna try to show you as much as I can. Meanwhile, I'm trying to repair them. So that's about it. So there's two different generation on those ones, and that one there's MOSFET missing. Why? I don't know. We're gonna take a look after. So skip this one for now because even if I want to see what's the problem with my tester, I'm using ARC, so ASIC Repair tester. If I want to see what's the problem, I might get more trouble after this because there's missing parts. So if I'm going to another one after that, nothing seems to be missing, but if I'm going to the other side, there's one chip missing and also the some of the heatsink are already gone. So somebody tried to make some repair. Is it me? Maybe I've worked on them like a few months ago. I don't even remember. So that's gonna be a good thing to see. Missing chip. I could start by that with this one and after this test. But let's see some other one. Also, what I like to do, the more I am advancing in the repairs, I like to take some notes on every board that you're working, just so you don't forget everything that you just worked on. So I might find some notes here right after. So physical checkup, same thing here. This is the last domain, so with the booster, so this is 72, 71, 70. Two chip are missing, but is it working? We can see it right after that. Seems like it's not touched that much. Oh, yeah, I see some problem. Booster right here, so booster is missing, so we're gonna try to put another one, but I got my own trick. Instead of putting all the parts, it's gonna be It's my fun part. So we're gonna put a booster on it to see if it's working. And also I just saw it's not a big deal, but just because I'm a little bit of a perfectionist, this part is missing. So I'm gonna take another one. I'm gonna take one from other board right here. I think it's a little LED. So we're gonna see what's going on. But it's just like a secondary part. The most important on this one would be huh, would be the booster. Also, even if all the chip, all the heatsink seems here, all the heatsink also seems all the same. So that's another good thing. But I got some mark here. It's not it's not a big thing, but I think somebody already tried to repair it, or I've seen a problem. Also, there's a little bit of burn here. So yeah, that might be yeah. So if I'm a little bit of burn right here, but also I've seen the LDO is not, it's okay, but it's not completely straight. That one neither, so that one is a little bit bent. Is it a problem? We're gonna see it right after. Okay, next. That one, it's heavily covered in flux, so much work on it. And also all those heatsink. So I think it's one of, I think I remember that bastard. It's one of the first one that I've worked with a few months ago. I think like not maybe 6 months ago, but almost. So yeah, I'm gonna keep it for the end because I don't want to go back to memory lane. I think it was a very like difficult one, and I've already seen some easier one to that I want to take a look. But who knows? Maybe another time I'm gonna check it. Next one, first domain. All the chips are, all the heatsinks are gone. All the remaining stuff, some flux here. Why? Okay. Okay, that one is could try something on that one. It's not that bad. Same thing here. Some chip missing. No, not chip missing, but heatsinks missing. I mean, some burn on the first and second domains. So that could be a problem. Who knows? Maybe the problem is corrected. Maybe somebody tried to repair it. Not much to say on that one. So this one was missing a part that has been salvaged from another one. So as I was explaining earlier, so some boards can have the same type of part but just different. Also, in your L3 Plus, when you are taking them, when you are unscrewing all the fans and all that stuff, and you want to pull out the board, take a look. It might be important to mark them. So hashboard 1, hashboard 2, 3, 4. Why? Because when you place them back, the the capacitors here, those one are bigger, and these one are smaller. So when you're putting them in the rack, sometimes they will not fit. And also, some of the heatsinks are not the same. So, by example, if I'm showing you this one versus that one, it might not be a huge difference to your eyes, but there's one actually, and sometimes it can be problematic. So just keep that in mind. Okay, what was I? This one, pretty beautiful, almost untouched. Last domain, some flux on the last domain, so that could be an indication of either a booster problem or something like that. Okay, chip. Click. Oh, chip missing. Cool. Other than that, yes. Good. A little mark right here. The two. Oh, okay, I've seen that one. So that one I will put it on the side for now. Yeah. First domain, I've seen that one. I should start. Yeah, that might be a good thing. I'm so used to work on the other side that I sometimes forgot to look at the more obvious side. So always take a look at the heatsinks. Heatsinks good. Some heatsinks, so that one is a little bit not bent, is a little bit sideways. So that might indicate that somebody has tried to work and it's in this zone. Let's see after. I'm gonna keep it on the closed one. Okay. Last domain. What? I think I've seen that one. Two last. Yep, two last. Yeah. Missing chip. Full chip. Full chip. I've seen those one. I'm just repeating myself. Okay. So, first one. Which one? First one I'm going. If I got too many of them, I just go, by the fill. So which one I want to work first? I'm gonna start with the. Okay, not that one. I'm gonna start with one with full heat sinks. Okay. So that one got its full heat sinks. No part seems to have left the board, so that could be a good thing. A little bit of work on this domain. Oh, let's see. Okay. So first thing first, let's plug that little L3 plus. What I am using is a power supply, a computer power supply, a VGA 850 G3, just a regular power supply. That what is cool also is that with the some VGA power supply already come with this kind of jumper, if you know what I mean. So it can start automatically when you give it signals. So with that in mind, if you want to plug safely your L3 Plus, you always start with the power, but the power supply is not on yet. And after that, I'm plugging my tester. Yeah, L3 Plus. And multimeter. I already have that one. Should be fine. Okay, everything's good. So now I can turn on my power supply. And then I can start my test. I can use that. I'm gonna. Okay. So what I will see? Oh, one and the other. So we got the two last domain problem, and it's jumping from one and the other. Sometimes there's a false soldering between the chips, and the hashboard. So what I like to do a little analog test. I'm just taking the board and I'm, if you see, I will just like bend it a little bit sideways just to see if it's reacting differently. And after this, what I can do, I can put some pressure on the 76 and then 77, and just like that, I'm just gonna move a little bit just to see what's happening. And if I am applying pressure, I just want to see the behavior. Doesn't change anything much. If I'm going to 67, it's jumping from one and the other, so it doesn't really matter. Okay, first thing done, I can just now check the values. I will see first return signal. Before that, even I could check if the LDOs are fine. So the one because the two last oh, little short right here. Everything's fine. The two last LDO are with the booster right here. So is my booster fine? My booster is supposed to be around 14 volt, and yeah, 14 volt. And on my LDO are supposed to be 1.8 volt. So you see, I'm just maybe not. There you go, 1.8. Oh, 1.3, and it's playing a little bit. I'm just gonna try. So you. Meanwhile, I didn't see it, but it's changed from 76 straight to 72. But I think it was because of the short that I did. So I just want to restart it. Okay. Strike two. 1323. This one would be like 1015. Could be the LDO. So I could start with this one, changing the LDOs. It might also be one of the chips of the domain. Okay, if I'm starting it again, doesn't really matter what I'm seeing, because I could check the return signal, but it might show me some errors. Yeah, because all the power, the 1.8 volt of the LDO isn't showing well. So that this is why those values are just messed up. So I don't take them really into account. So I got last domain LDO problem, but that might not be the LDO. That might be the chip sometimes, from what I've seen. Okay, power supply off. Let's go to. I'm just. Do I got? Yeah. Notes. I'm gonna take bigger one. Wait. Oh, what a guy. On m'entend dessus? Okay. 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 I'm back. Notes. Better notes. Bigger notes. Uh, so last. Oh. So LDO 11, 12. 11 was like 1.3, 3.5. Stop at 76, 77. Okay. Next one. Nope. Chip. That might. So this one, let's see. Power supply on. Oh, almost full board. Almost. All the parts. So I got my step down here. That's supposed, yeah, 10 volt. Yeah, that's around 14. That's still very great. And anyway, it's. Is it my probes? Ah, 1.7. 1.7. Okay, so here I got a problem of a almost full board. That could be either in that case, that may be the last chip or the one before it, because the, but these seems not change if I am comparing. Oh, that's nice. Okay, here if if I'm making a comparison, those two, you still have some thermal glue on it, and there's no flux around indicating that these are still exactly the same. But if I'm comparing to this one seems new, this one seems new. Those two ones seems not changed. So I don't think these are the last. I think it was an attempt to see if these were the last. So one thing that I could do before changing the chip, will try to do what we call a jumper method. It consists of jumping the return signal with the capacitor showing 1.8 voltage from the LDO. So if I'm powering again, I will try to see. Yes. Okay. So if I'm looking, for example, do you see quite clearly? Here. There's even four capacitor right here. First one is 0.8, second one 0.9, 1.8. So this would be the third one that I will try to use. Then the last one 0. So it will be the third one. I will go fetch my jumper. As I said, I am not at my desk, so everything is on the other side. But one shall always be prepared to the unexpected. Huh? Wait. Jumper. Yes, I am. What? Lol. All right. So it's just regular wire with pointy ends. Yeah, it's gonna be better to make it short. And these are pretty small, so I'm gonna change that. Tack. Okay. Ah, power. Okay, I just need to adjust a little bit. Okay, jumper. So that consists of seeing what the tester is gonna show me. Whoop, you don't have the tester right now. Do I have one? Nope. Okay, it's not that bad. I really want you to see what will be the behavior. So as I said, I taking the third one that is showing me 1.8 volt, and I'm jumping with the return signal. So you see, showing me 70, and I'm doing that until something is making the double of the signal. Yeah, yeah, yeah. Mm-hmm, mm-hmm. This one great. And also one nice, we can consider it nice versus the 17 gen is that the L3 pluses doesn't eat heat at all. So I can just go on and on and on with my testings. Okay, okay. That's not nice. Still nothing. Right? Oh, oh, I went too far. That one. Yeah. All right. Thirty-seven, 36, 35. Okay. What I could do just to be a little bit faster for the last ones. So this one is showing me. I'm just gonna take the last ones. Yeah, yeah. What the? Okay. So that might be something else. 5, 4, 3. Oh, wait. 3 and 3. So you've seen here. All right, all right, all right, all right. Starting here. 5, 4, 3, and showing me again. 3, and then 2, 1, 2, 1. Okay. So that one and the other one. 3, 3. So that one seems to be the issue. All right, let's repair some stuff. First thing, always putting out the heat sinks, otherwise it's gonna be quite difficult. Hmm. Ah. Hmm. So I was a little bit wrong earlier. Those aren't the last domain. Those are the first domain. I just didn't take a look enough because obviously the power is right here, first domain. So it's just like same thing reverse. And so you see something as stupid as that. So a work was already been done here, and also the problem is right here. I thought it was completely on the other side, so that's just my mistake. I should have started with that. So one of those two is creating the problem, but those two are brand new. So usually it's one or the other. So I will start with the second one. Cat leveling. So for the temperature, I'm going around 470 Celsius and 45, around 50% of air. With but it always depend with your workstation. In that case, I am working with an Atem ST872D, very great working machine. There you go. And what I could do, what I am usually doing here, I will try to reapply correctly all the tin, so it will be flat. Because if there's bumps, your chip isn't gonna stick very well. Chips, 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 chips. So putting the other one on the side, even if it's a new one, it might be good. It might be the application, but personally, I prefer to just make a new application with another chip. And I might even use used ones because sometimes these are working better. So I got this one here. All the chips are here. A little bit of flux. All right. And I like to use these to just apply a little bit of pressure on the chip just to see if it's well flat. All right. Cooling it. I'm still applying light pressure until it's well soldered, like something like 10 seconds. And if I'm looking, so that one is a little bit on the side. I should redo it. I didn't saw because usually I got a lens. So speaking of lens, what I could use is protective glasses, and I got this little. Oh yeah, oh yeah, 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 yeah. It's working. Now we're talking. Okay, let's try it again. Yeah, that one. So now I am at 400, at maximum 480 and about 30% air. But I could slow down a little bit to 450, might be safer. Okay. Little soldering ball. Okay. A little bit better. Here, that one. A little bit better. All right. So let's pull it on the side. Let it cool a little bit, a few minutes. And then let's see. Next one. Tu vas? Ciao, Sam. Oh, booster. So I could scavenge from one or of our dead board. For example, that one that I think it seems hardly repairable. So I could take those parts, but some of the parts might be eternally burned. So I just prefer to change it all the way and add what we call a booster circuit. So that one. Booster! So that one is literally replacing the old one. If I'm comparing here, so we got almost the same parts. So we got a little chip over there. We got that one. We got those ones. It's quite the same. So this one is specifically for L3 pluses. So it's shooting. It's taking 10 volt up to 14 volt at the end. So how do you plug this? So most of the time, how are the L3 plus working? They're taking the 12 volt from the entrance, going down to the step down here. That is shooting 10 volt that you can have access here. The 10 volt is giving life to all the 10 first domain up to the domain 10, and the two last one are taking the 10 volt to 14 volt, and then the 14 volt is going down to the two last ones. So what we will do, we will make a little bit of soldering. Oh, nice. 1, 2, 3. So I will prepare the booster application. Got here, and also here. So I'm going to 470 and 50% air. That doesn't really matter. I just want to pull the parts out, so I'm just stripping. All right, so it's good. I was just making sure that the welding was nice. Same thing here. Everything is already stripped. I just want to see everything is well melted down. There you go. Okay. So you got your entry in, positive, negative, that is taking the 10 volt and going out to for a 14 volt application, and that one is going to go. A good place that I found is C1072. That's going to be the output. There you go. Oh, there's a little bit of flux, and I'm also gonna need some soldering tin. 1, 2, and 3. Yeah. I didn't put flux on that one. I just want to make sure that the soldering is a success. There you go. Beautiful. Beautiful. Okay. Now, meanwhile, it's cold. It's getting itself colder. Let's take a look at this one. What I could do, I could start with a diode test. What do I have? Alcohol, I don't think. Okay, and I can make a little diode test before doing anything else, just to see if the chip seems to be in a good position. Okay. So in the case of diode test, I am always reversing the probes. So instead of having the ground, so the negative onto the ground, I'm taking the positive one. In all the even with 17 gens and 19 gens is the same way that Bitmain is showing how to do and the values that we can find. So I'm starting with the first one for 46. Oh, 447, nice. Again, maybe BOBI, yeah, good. That one too. 443, yeah. And return signal. All right, that seems great. Now, let's do the test. Ultra Plus, Nakita. Ah, oh, it's still the same thing. If I'm jumping. So that would be the other one. So at least the position of the chip is fine. The chip that I just placed again is nice. Okay, three again. Okay, so it's gonna be the other one. I'm pretty sure. So we can straight work on that one. I like to leave some mark before making any changes. So that one has been done once. So I'm going to take that one. That one is done. I could put flux for easier removal, but there was already some on it, so that should be fine. Let's go again. Okay. So that one, there's a little pop. Uh, 30%, 465. Shit. Well, that should be good. Hey, there you go. Oh, that seems nice. Okay. Now it's booster time. Reset. And that part, that little part I forgot right after. I don't think that's gonna change big stuff. So will it work? There you go. Little LED light, so it's working. Do I have my values? 10 volt, 14. So the booster is working. Last domain, 1.8. Last domain, 1.8. So that's working. The booster is working, but there's something else between 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Even that one. Hmm. What's happening on this one? So a bit of analog testing. If I'm bending a bit, oh, oh, that's really messed up. Okay, now I can take more values. I will take the clock, starting with 43. No, okay. You see that one is really messed up. So maybe not clock signal right on. I will try return signal first. Yeah. So return signal is jumping all over the place. It's jumping all over the place. I don't really like this LDO right here. It's a little bit on the side. So on those scenario, what cause, because all the problems seems to be around like those two or even three domains, but why is it going further? So that's indicating me that all the chips Almost all the chips are fine. There's just one that is messing out. And most of the time it's the case. So which one are coming back the most? 42, 41, 42, 41, 42. There's no part missing. Okay. Hmm. 1, 2, 3. So that might just be like a bad connection between a chip and the resistance or a capacitor. Or that might be a chip that got a false soldering, but I didn't found it yet. So no work here, no work done, but here maybe I could check the diode test, but it's a little bit hot even for L3 plus. So something is definitely going on. Now this one. Oh, diode test first. A bit of cleaning. Yeah. Ah, before testing. So when you're making diode test, never plug the power supply nor the tester. So that's fine. Hmm. Yeah. Oh, values seems fine. That's looks like it's a good welding. There you go. So jumping problem. Not yet. Maybe there will be advanced test problem. Why? That's already a little bit better, but that might be a problem. And you see sometimes when you're doing it again, sometimes the Ultra Pluses are showing okay, but it seems to have a little problem still with one chip. If I'm trying to look at the temperature sensor, and temperature sensor showing, and then it's all green. So maybe there's, there you go. Between the 5 and the 6. So chip problem is not is great, but not temperature sensor. If I'm making a little bending, nope, nope. So there's like one chip that is causing that problem. Because first it's detecting and it's working, but now, yeah. And we changed some chip around the temperature sensor, so that might be something around. So what I will do, I will try to check my return signal. Not my return signal, my BI signal, just to see if there's something wrong. Put the start on the test. And BI is supposed to show something like 0. Yeah, yeah. And also the behavior of the L3 pluses, the last chip of every domain is showing something on the BI, around something like 100. 101, and it's pulsing. But that seems like a normal behavior. So if I'm going again, is there a weakness with the return signal? Oh, it's jumping. So it goes 1712, 1712. Yeah, I'm going here. It's jumping too, so same thing as the other one. This one is jumping, but not that much. All, all the circuit is jumping just a little bit to be annoying. No missing parts. So that one, it will be a little bit longer to take a look. So if you got some testing machine, I would suggest to try to put it in Vinish. Vinish could show you some maybe some chip map and chip problem if there's some, and also with the temp sensor if it's really working or not, because the behavior is strange, but at the start it was showing good values. So I would try to put it in the machine first just to see if it's really going wrong, if something is really going wrong, because I've seen today that the ARC testing machine, some of the ARC testing in the last update have some difficulty with C5, I think, and L3 Plus including. So they are trying to make a debug, but it's not done yet. That might be it, that might not be it. But to find the chip, if there's one that is causing the return signal jumping, that will take quite a lot of time. And for the L3 pluses, right now I got many others. So it's half repaired, three quarters repaired. So that's a small win, I think. It's not worse. It's better than worse. So if I'm taking that one, I do want to stop at 6. Why? Okay. Okay. That one is good. Let's see. That one. That one I want. That one is really messing with me. So I will change it for another one. And also we'll add this little part just to see if something is changing. And I don't know if you see, always try to have the same LDO. That might be an important thing to do. 4VK4. And it's just happening that my deadboard have the same. And also that little part that I want on the right side. There you go. So full power 480 and 45% of air. A little bit too far, we'll just put those lenses. There you go. Third eye. Oh, I was blocking the air. There you go. All right. Okay. 470. There we go. Okay. Just want to cool it a little bit. 3, 4, 5. A little bit on the side. There we go. That one is like the first time that I'm seeing it's missing. So I will go a little bit with a bit less heat. You see, yes, good. Eh, whoop. I think the little glass screen on it or something just fell off. Yeah, let's try another one. That happens. So yeah, that one there's definitely with the chip there's too much work, so I'm gonna take the part. Okay, so with what I will try to do, I will try to take it from under to put less stress on the part. All that time for one small part. Mm, okay, it seems to fall off. Woo! Nice. And once it's placed, there you go. Hey, a bit on the side. Hi! Really? You didn't saw anything about it. Hi, bro. Good afternoon. I see there's some L3 Plus enthusiasts. You. That part seems so fragile. Whew. I don't think this soldering will be a success. It seems so fragile, and also there's still the last part remaining, but now it's fine. Well, oh yeah, almost forgot. Get some notes. What cat? Oh, okay. Change. 71, 72. No. Check temp sensor on the other one, just in case of. That one. BL. Bit. LDO number 8. And also TF. New booster. That one. And speaking of LDOs, let's see if this is an LDO problem or a chip problem. There you go. So we're gonna change them, and we're gonna see the results. And Victor or not, I think it's gonna be quite enough for today. You cannot always have 100% victories. That's part of the game with the miners. At least I hope it helped even a little. Or if even you had fun watching, that's a good thing. There you go. So that one, it's called. Oh, the power supply wasn't off. It's not a big of a deal, but it's just better to close it every time and open it up right after when you need it. Well, oh, okay. Hmm. So it is surely not a LDU problem. Yeah. Yeah. That one will be problematic. So those probably all those that I had remaining were like the hardest one because behavior like that when you see the chip map, there's something really strange going on. Okay. So a little follow up on that one for next time. and let's compare values. Same thing. So this is not. On 0.5. Yep. So LDO aren't the problem, but it's the first thing usually to do with the last domain. Many times it happens, but that also means that the LDO that I took are still good. So I will keep them on the side. And the other one also for VK4. Okay. If you understand yourself on your notes, that's the most important part. Diode test. Why? Because I want to see the behavior of the chips. So if I'm checking that one, it's great. For 61. All great. All around 430, 439. So even if diode test is good, that doesn't mean that the chip are good. I could check the two, like those two little capacitors. As I said earlier, these are for the LDO voltage. So one is 1.8, the other one is 0.8. So what I try to do, I try to see on another domain what it's showing me. So the first one on the right is showing me 40. The other one is 22. So I will check where it seems to have some problem. 40, 22, 40, 22, 39, same thing. 40, 40. So be sure that your connection is good. These are quite small parts. So what I try to check is one of those chips is causing the problem. Is last one? No, 42. Okay. So the next step that I will do in that case would be to change at least the chip 70, 67, sorry. I would change the chip 67 because it's the closest one to the LDO under it, and it might cause some problem. Might also be the 66, but I will start with the 67. And after this, sometimes I've already some board that it was another chip that was causing the issue. So I could continue to check all the signals, clock, return signals on all the last domain, BI also. That might be important just to see the behavior if something is going away from the norm of the other chips. But that's gonna be another time. So thanks for watching. I hope that you learn. If you learned anything today, that's good. So even if it's not a victory, we always learn a little bit every day. So bye bye. So how do we close? There we go. Okay. Ciao, ciao.